Hey folks, so this is Roshi the Expert Audio doing a voiceover this time. So these are the Eden boards that we've been testing recently, and so I just want to show you to start off with. I've created a tracking labels and so on. This is me trying to be a little bit more pro, but you can see here this allows me to track whether it's a rework or a new build. I've got a name here, so rebuild there. The name is Pablo. This is Pablo's second board that he sent back to me. There's an RMA. I haven't set up a database for that yet, but the main thing here is I've got notes as well for me. Then on the back, there's the 4 tests I have for each of these Edens. So for instance, I start off with a testing ground to 15 volts, shorts on power and so on. Then we test the inputs to make sure the input resistors haven't been changed by some drastic soldering. We've seen some 12 ohm resistors get messed around with and so on. If people do some butchering and soldering. And then we do THDN tests. So we do the THD at minus 30 dB with 30 dB of gain, and then we do the same thing again with minus 60 with 60 dB of gain. This is the board we test with. So there's pogo pins on the board, and then those pogo pins are then brought up and they make contact with the PCB at these points as well. And so what it allows me to do then is to actually just put pressure down on the board and hold it in place. Now no power is applied at this point either, so the board is pushed down. There's some standoffs there to help center things up, and once things are ready, then I can switch the board on. So and switch the board on, you see 2 red LEDs that come up. The 2 red LEDs are there to tell me that plus or minus 15 volts are working on the board. They are left on the board there as well for you to use in your systems at home. And then I fire up the audio precision, and what we have here is a test setup. So we do a test between 20 kilohertz and 20 hertz of distortion versus frequency sweep. So we put minus 30 dB in, or dBu I should say, minus 30 dBu signal in. We turn the gain pot on the test jig for 30 dB of gain, which should give us about 0 dBu ideally. Given it's a normal sort of 12 millimeter potentiometer, it doesn't hit exactly that, but again we're looking to make sure that there's nothing weird with the board. And you'll see it here that we're at 0.003 dB or so, and it's linear as well up to 20 kilohertz. It's actually beyond 20 kilohertz, but we set it up for that just for this test. So I'm pretty pleased with that. That to me looks like a pass. So at which point we would tick that off in the appropriate form. So we grab the label, switch the board off, grab the label, tick it in the right place, and move on to the next board. And the next board then will come on, be tested, and so on. So we do all the 30 dB tests together. Now the next steps in the development of a board like this really are, if we were shipping way more Edens, what I'd be doing is using the audio precision to actually control external relays and so on, so that we could set it up, with pre-trimmed gains and so on, and then do the test for 30 dB, closely followed by the test for 60 dB and so on, and switch on the power supply and all that, all from one push button. Now that's that's kind of like the real pro way of doing things. Now let's look at the next board. This is board number 3. Now on this one I actually kept the ICs on board, but I noticed that the input resistors were much higher than the 12 ohms it was supposed to be specified as. And these boards wouldn't have passed the functional test the first time around. So a bit of a strange one there. I suspect some heavy-handed soldering of capacitors and so on went on there. So again, we put the board down, switch the board on. I've actually replaced the 12 ohm resistors beforehand, and go back to the audio precision and again run the same test, and we should be seeing that blue line again down at 0.003% THD. Beautiful stuff. I'm very happy with that. Occasionally we get like a high at DC, and we test again. Now that the boards have been tested at minus 30 dB with 30 dB gain, now let's do the 60 dB. So we take the same board, back on the jig, gently, and let's try that one more time. There we go. Make sure it's good. We then apply power. So I need to get a hold down for this jig and switch over to the AP view. Now I need to put in a minus 60 dB. There we go. And we're going to look for the input signal to be up at around 0 dBFS. Sorry, 0 dBu. And so with that, we dial it in, and we've got to change the gain now manually next to the board to make sure we're at maximum gain. And you'll see we eventually get to roughly the 0 dBu. Sometimes it'll be like minus 0.5 dB or plus 0.5 dB, and we run the sweep. So here comes the sweep with minus 60 dB signal with 60 dB of gain. And with all that gain comes higher THD. There's no getting away from that, but we're still at a very respectable 0.03% THD. Virtually unaudible for most users. Big lesson here I actually learned very quickly was that if you have like your power supply lines, your AC power supply is running near the PCB here, it can actually couple into this signal because you are gaining up the signal so much. So lesson there is keep your traces far away. So at this point we've now tested 3 boards, and I gotta tell you something, Pablo, you need to be much less of a butcher when it comes to soldering, dude. There's an expectation you've got to solder a couple of capacitors around this board and headers and so on, but it looks like input resistors, surface mount ones, can't really take that temperature really well. So next time maybe we'll just get you another soldering iron. Well, with that, boards are done and dusted. All 3 of them have been tested, and they really are working, ready to be sent out again. So again, here are the Eden boards, great mic pre's, very easy to assemble, up to 60 dB of gain. And you know what? Job done, everybody. Thanks for staying with us.